Hello everybody, this is Mr. Basil, and let's get to it. So in these video notes, I'm going to be covering the basic principle that is going to be present for learning targets 6.3 and 6.4, which is about stoichiometry, and I'll define what that is here in a moment. But the main focus is being able to understand how to use a BCA table. All right. So let's see here. So learning target 6.3 and 6.4 stoichiometry. Here's your definition of what stoichiometry is. It's about looking at the relationship between reactants and products to make predictions about how much stuff is needed or will be produced in chemical reactions. And to start, we're going to talk about the s'mores activity that you did if you're here. And yeah, we're going to use that to kind of frame and use the experience of that to help you understand, the difference between the reactants and products, how much is being made, and so on, and how can we make those predictions. At the end of the day, it's going to be all about moles. You'll notice that because it's about a number of things. So if you think about the s'mores activity, you had a number of graham crackers and a number of chocolates and so on, and that's what we did all of our calculations based off of, not grams or individual particles. I think I can fit right there, yes. And then a few other terms that came up in that activity were limiting reactant. This is the thing that runs out first, and this is what limits the reactions. And then you got your theoretical yield, which means given the information, how much product can be made. And then, it looks like that got cut off, I apologize. Excess reactant, so what that says is excess reactant is what's left over once the reaction is complete. So, your leftovers. All right, so let me just see if I can move myself here. This was the, quote, reaction for the activity, where you had one marshmallow and 2 graham cracker squares and 3 little pieces of chocolate. That makes one s'more, right? And then the chemical formula for the s'more would just be those things put together. And I told you, okay, let's say that you have 200 marshmallows, 216 graham crackers, and 350 chocolates. And it was up to you to decide how much of each thing. If I just had 200 marshmallows and I didn't have to worry about the other things, how many s'mores could I make? And this is what a lot of you came up with. That 200 marshmallows, well, that could make 200 s'mores. 216 graham crackers, that could make 108 s'mores. 350 chocolates, that could make 150 s'mores. And you might be thinking to yourself, well, wait, how is that calculated again? I can't quite remember. And, all that you end up doing is just saying, okay, well, 200 marshmallows, 1 marshmallow equals 1 s'more, so for every one, well, you probably didn't even have to think about dividing by 1, but really that's what you're doing here. And then for the graham crackers, that makes 108 s'mores because 2 graham crackers makes 1 s'more, so you have to take this number, 216 divided by 2. So you'll notice that you're dividing by the number that's in front of the formula for the graham crackers. And then 350 chocolates, it's a 3-to-1 ratio, so you need 3 chocolates to make 1 s'more, so you divided that by 3, and we found 150 s'mores. And then looking at this, we can easily see that, well, we can only make 108 s'mores then, because 200 compared to 108 compared to 150, yeah, that's pretty straightforward, right? Whatever runs out first, right, the graham crackers can only make 108 s'mores, so the 200 versus 150, that's not going to happen, right? You're gonna run out of graham crackers. So then I had you put everything into a table that looks a little bit like this. Let's see, now I'm over here. Okay, I'm realizing as I'm recording this that I've been trying to move my video to different spots so that way I wasn't covering up things. And I'm realizing now that I might be covering up something this whole time, and so I apologize if I'm covering up the equation. Excuse me. Should be 1 marshmallow plus 2 graham crackers plus 3 chocolates equals 1 s'mores, which is Mg2CH3. Anyway, so had you do a table like this where you had your before, change, and after represented for this, where the before, this represents before you do anything, what do you have? The change is, well, after you've made as much stuff as you can, what changed? And then the after is just, well, what's after, right? After you're done making all your s'mores, what do you have left in front of you? And so there are a few things that you can fill out first immediately to represent everything here. That you have your 200 marshmallows, you have your 216 graham crackers, and your 450 chocolates. We also know now that we could make 108 s'mores. And so I put that in the after row for the s'mores, because before we make any s'mores, we do not have any s'mores. So this also we can fill in as a 0. The before for the products is always going to be a 0. And so then the change that has to be, in order to go from 0 to 108, I have to add 108 in the change row in order to get to 108. You'll notice for the change rows that there's always going to be pluses and minuses here, because that's what a change is, right? You're either adding or subtracting something. So now it comes over here if we want to fill in the rest of this table, and this part maybe was a little confusing if you remember going through this, but the things that we know for a certainty, I've already started to kind of fill that stuff in, and we know that if we're going to make 108 s'mores, we're going to use up all of our graham crackers, right? We had decided that making 108 s'mores requires all of our graham crackers, all 216. Another way to think about that is if you have 108, you multiply that by 2, that gets you back to, seeing that, oh yeah, I'm going to use up all of these. So in whatever the case is, we have 0 graham crackers left. Now, the next tricky part is figuring out the change for the marshmallows and chocolates, because it's not going to be 108 necessarily. Well, it could be. And it's also maybe not going to be 216. It's unique because each of these ingredients requires a different amount in order to make your 108 s'mores. So let's think about the marshmallows first. I have 1 marshmallow makes 1 s'more. So if I'm making 108 s'mores, that's just 108 marshmallows. Differently though, I have 3 chocolates makes 1 s'more. So I need 3 times whatever I make for my s'mores in order to get my change for that one. So 3 times 108 gets me 324. Then the after, this is just a simple addition or subtraction. Oh, I forgot my minus sign here. This one should have a minus sign. But 200 minus 108, that gets me my 92. And then the 450 minus 324, that's where I get my 126. So now you can see in this BCA table, the before, change, after table, that I can see how many things I have left from my ingredients, right? My excess is my marshmallows, my excess is chocolate, my limiting reactant is the graham cracker because that limited everything, and then my theoretical yield, or how much I produced, that's my 108 here. I'm going to go over one more example in the slides like this, but I'm going to use chemicals this time. In the next video, I'm going to go over more examples on how to, do many different kinds of problems. So, here we go. I'm realizing now what you cannot see behind my face is a picture. So in the picture there are 3 light circles, or 3 sets of gas particles, and then 3 sets of black gas particles. And so the question is, well, how many products can we make based off of this equation? So I'll just tell you, we're starting with 3 N2s and 3 H2s. Just like how before I said, oh, you have this many graham crackers and chocolates, I'm going to say that we're starting with this many things. The first things that you should always be able to do is put the given information in your BCA table. Sometimes it's going to be before, sometimes it's going to be after, but you should always be able to start with that. One thing that will always be true is you'll never have any products before you do a reaction. So you'll always have a 0 here. All right, so now we have to decide which of these things is going to get used up first. You know, and in the previous example that we did with our marshmallows, we did a few different calculations to figure this out. But the strategies I'm going to show you is how can you navigate this no matter what information you're given. What is the process that you need to go through in order to figure out how many leftovers do you have and how many things do you make in the end. So 3 moles and 3 moles. You might notice here, oh, I'm going to use up 3 times the amount of hydrogen than nitrogen. The hydrogen is going to go away 3 times faster than the nitrogen. And then I'm going to make 2 NH3s, ammonia. I'm going to make 2 NH3s, so that's going to be, factored in as well. So you can probably see already that we're going to run out of H2 first. That's going to be our limiting reactant. And here's how you'd calculate this. So you say, well, what's the limiting reactant? Well, the way we do that is we take the given information and we divide it by the coefficient. So 3 divided by 3 gets me 1. 3 divided by 1 gets me 3. So whichever one of these is smaller, that's what's going to tell me what I'm going to run out of first. So this one, the H2, is going to be my limiting reactant. And we're going to use this information to calculate everything else. So you're going to multiply the limiting reactant factor, this number right here. Excuse me. We're going to take this and we're going to multiply it by the coefficients of everything to figure out the change row. So 1 times 1, 1 times 3, and 1 times 2. And we get 1 for N2. We get 1 times 3, we get 3 for H2. And 1 times 2, we get 2 for NH3. Now, the other thing that we have to do is we have to gain products and lose reactants. So it's just like the s'mores, right? We're going to make s'mores, we're going to make NH3, so we have to put a plus sign here. And then we're going to use up N2 and H2, right? Those are going to disappear as they get used up. So I'm going to put subtraction signs on the left and addition signs on the right. And then the last step is just a simple addition or subtraction. So the nitrogen is going to lose 1 mole, and H2 is going to lose everything, right? One thing is usually going to lose everything because you're going to have a limiting reactant, right? The H2 is the thing that limits the reaction, so that way there's nothing left. And then 0 plus 2, then we end up with our 2 moles of NH3 in the end. So what this will look like if I just had 1 particle for every mole, I'd end up with 2 molecules of NH3, that's this here, and I'd be left with 2 molecules of N2, and nothing of H2 is left. Alright, that was a lot of stuff, but in the next video I'm going to go over 3 examples of problems just like this to show you how you can navigate solving the different kinds of problems you're going to have for stoichiometry and BCA tables. Alright, thanks for watching, and see you next time.